What is machine learning and how does it work? In this episode, we explain how computers learn from data instead of following fixed instructions. Using examples from farming, education, and daily life in Africa, we explore how AI systems recognize patterns, make predictions, and get smarter over time. From teaching an AI to identify fruits to helping farmers spot diseases, this episode makes machine learning fun, easy, and practical. You don't need to be a computer expert, just come with an open mind. Let's get started. So, what is machine learning? Simply put, machine learning is when computers learn from data, just like humans learn from experience. Usually, we give a computer a list of instructions. Do this, then do that. That's called programming. But with machine learning, we don't give detailed instructions. We give the computer lots of examples, and it learns to recognize patterns and make decisions based on those examples. It's like teaching a child. Let's take a simple example. Imagine you're teaching a child how to recognize a goat. You show him several pictures of goats and say, "This is a goat." You point at one in the village and say, "That's a goat." After a while, he starts to recognize goats on his own. He sees one in the market and shouts, "Goat!" Why? Because he learned from examples. That's exactly what machine learning does. You show it hundreds or even thousands of examples, and it learns how to recognize things or make decisions. Now, let's break down the process of machine learning into 4 simple steps. We'll use a fun example, teaching a computer to tell the difference between a mango and a banana. Step 1. Collecting data. First, we need to collect data. Data is information. In our case, it's pictures of mangoes and bananas. Let's say we take 1,000 photos of mangoes and 1,000 photos of bananas. We label each photo, mango, banana. These labels are important. They tell the computer what it's looking at. This is called labeled data, and it's very useful in machine learning. Step 2. Training the model. Next, we use this data to train a machine learning model. The model is like a student. It looks at all the photos and starts learning patterns. For example, it might notice bananas are usually yellow and long. Mangoes are more rounded and can be green, yellow, or orange. The more examples it sees, the more it learns. This part is called training. It's like how you get better at recognizing fruits the more you see them. Step 3. Making predictions. Now that the AI is trained, it's time for a test. We show it a new picture, one it has never seen before. We ask, "What fruit is this?" If the training was good, it will look at the shape, color, and texture and say, "That's a mango." That's called a prediction. It may not always be correct at first, but with more training, it gets better. Just like a student improves with more practice. Step 4. Improving over time. The final step is repetition and improvement. Every time the AI sees more examples, it learns and adjusts. If it made a wrong guess, it learns from that mistake. If it made a correct guess, it strengthens that knowledge. This process of learning from experience is what makes machine learning so powerful. Machine learning is all around us. You might be wondering, where do I see machine learning in my life? Let me show you. WhatsApp Auto. Correct. When you type in WhatsApp and it corrects your spelling, that's machine learning. It learns from what people commonly type and suggests words. Google Maps. When Google Maps shows you the fastest route to your destination, it uses machine learning to learn traffic patterns. In Lagos or Nairobi, it learns when traffic builds up and gives you a smarter route. Music apps like Boomplay or Spotify, learn the kind of songs you like and suggest similar ones. That's machine learning using your listening history to make smart guesses. Farming and machine learning. Let's go to the farm. In Uganda, there's an app called Nuru that helps farmers detect crop diseases. Nuru is a mobile AI assistant that works inside a standard smartphone and is capable of accurately diagnosing plant diseases offline without an internet connection. Here's how it works. A farmer takes a photo of a leaf from their plant. The app compares the photo to thousands of pictures it has seen before. It identifies spots, color changes, or damage. It tells the farmer if the plant is healthy or sick. That's machine learning at work, saving time, money, and improving harvests. Machine learning in African banks. In Kenya and Nigeria, banks use machine learning to protect your money. The AI learns how you usually spend money. So if someone tries to withdraw your money in another city at 2 a.m., the AI can say, "Wait, this is unusual." It blocks the transaction and sends an alert. That's AI learning your behavior and protecting you. Education and learning patterns. Some schools in Ghana and South Africa use learning apps powered by AI. These apps watch how students answer questions. If a student is strong in maths but weak in reading, the app adjusts and gives more reading practice. That's machine learning, personalizing education. Let us now explore 3 simple types of machine learning. 1. Supervised learning. You show the machine examples with the correct answer, like showing 1,000 mango photos and labeling each one as mango. The machine learns from the labels. This is the most common type and works well when we have lots of labeled data. 2. Unsupervised learning. Here, you give the machine data without labels. It looks at the data and tries to group similar things. For example, if you give it photos of animals, it might group cats together, dogs together, and birds together, even if you didn't tell it the names. This is useful when we want to find patterns we didn't know existed. 3. Reinforcement learning. This is like teaching a dog with rewards. If the AI makes a good decision, we reward it. If it makes a bad one, we correct it. This method is used in games, robotics, and even self-driving cars. You don't have to be a computer programmer to try machine learning. Google has a free website called Teachable Machine. Here's what you can do. Go to teachablemachine.google.com. Click Get Started. Upload pictures, like your face smiling or frowning. Upload different kinds of picture. Train it by following the instructions in teachablemachine.withgoogle.com. Test it with a new picture, but similar to the ones used for the training. You'll be surprised at how fast it learns. Even 12-year-olds can try it. Let's review what we've learned. Machine learning is when machines learn from data, not instructions. It works by showing examples and letting the computer find patterns. It's used in daily life, on your phone, in farming, in banking, and in schools. There are different types: supervised, unsupervised, and reinforcement. The more data the AI sees, the smarter it gets. We've just scratched the surface of machine learning, but now you know how it works and how it's used every day in Africa and beyond. Please like this video, subscribe to my channel, and share with friends and colleagues. Remember, AI is not just for Silicon Valley, it's for smart Africans like you. Let us now examine how a computer sees, also known as computer vision. Computer vision allows machines to analyze images and videos so they can recognize objects, people, scenes, and even actions. You know how you can look at a picture of a tomato or a football and know exactly what it is? Well, AI can do that too, not because it has eyes like us, but because we teach it to recognize objects using data and examples. How do humans recognize objects? Let's start with ourselves. Think back to when you were a child. How did you learn to recognize a tomato? Maybe someone pointed and said, "This is a tomato." You saw that it's round, red, or green, and has a certain shape. After seeing tomatoes in books, at home, and at the market, you learned to say, "That's a tomato." Even if the tomato looked a little different, small, big, ripe, or not ripe, you still knew. You learned by seeing many examples. That's exactly how AI learns, through lots and lots of examples. Unlike you and me, computers don't have eyes. They see through cameras, but they don't really understand what they're looking at until we train them. Let's say you take a picture of a house. To a computer, that picture is not a house. It's just a grid of numbers, millions of little squares called pixels. A pixel, short for picture element, is the smallest unit of a digital image or display. It is essentially a tiny square or dot that holds a specific color and brightness value. When many pixels are placed together in a grid, they form a complete image that you can see on screens like your phone, computer, or TV. Each pixel displays one color at a time. Pixels are arranged in rows and columns to form an image. The more pixels an image or screen has, the sharper and more detailed it looks. This is known as resolution. For example, a screen resolution of 1920 by 1080 means it has 1920 pixels horizontally and 1080 pixels vertically, totaling over 2 million pixels. Each pixel has a color, a brightness level, and a position in the grid. The AI looks at the numbers behind the image, not the image itself. Example, an aircraft photo. Let's say we show a picture of an aircraft to an AI model. It doesn't see white, fuselage, or wings of the aircraft. It sees something like this. Pixel 1, yellow 60% brightness. Pixel 2, white, 65% brightness. Pixel 3, brown spot, 50% brightness, and so on. AI starts to notice patterns in the numbers. Over time, it learns. When I see this combination of yellow, white, black pixels and curve shapes, it's probably an aircraft. That's how AI recognizes objects. Let us now examine neural networks, AI's learning brain. To help machines learn patterns, scientists created something called neural networks. These are computer systems that are designed to work like the human brain. Here's how it works. The AI receives an image like a beautiful lady. It breaks it into pieces, tiny pixels. It passes the information through layers of the network. Each layer looks for something: edges, curves, colors, textures. The final layer makes a decision. This is 90% likely to be a beautiful lady. It's like teamwork. One part of the AI looks at color, another part looks at shape, another checks for facial appearance. Together, they make a smart decision. Let's say you want to teach an AI to sort human pictures: children, adults, men and ladies. You collect 500 pictures of each. You label them correctly. The AI trains on these human pictures. Now, when you show it a new picture of a lady fruit, it says, "I think this is a lady," 95% confident. If it's wrong, you correct it, and it learns again. This is called image classification, a key part of computer vision. Key tasks in computer vision include A. Image classification, identifying what an image contains, e.g., this is a dog. B. Object detection, finding and labeling objects within an image, e.g., spotting cars in a traffic photo. C. Face recognition, identifying people's faces. D. Image segmentation, dividing an image into parts for better understanding, e.g., separating the background from the subject. E. Motion tracking, following the movement of objects in videos. In short, computer vision helps machines to see and make decisions based on what they see. 1. Crop disease detection. Farmers in Uganda and Kenya use the Nuru AI app to identify plant diseases. Example: a cassava farmer sees yellow spots on the leaves. She opens an app and takes a photo. The app compares the photo to thousands of pictures in its database. It checks color of the leaves, shape of the spots, location of damage. The AI then says, "Your plant may have cassava mosaic disease." And just like that, the farmer knows what to do, thanks to object recognition. 2. Face unlock on smartphones. Millions of young people use phones that unlock with their face. Here's how that works. The camera captures your facial features: distance between your eyes, shape of your nose, curve of your lips. It turns your face into a unique map of data points. Each time you unlock your phone, the AI checks if your face matches the stored map. That's AI recognizing your face as an object, and it gets smarter every time you use it. 3. Traffic cameras and license plates. Traffic systems use AI to recognize cars. Cameras scan number plates. AI reads the letters and numbers. It checks for expired tags or unpaid fines. It even detects vehicles speeding or running red lights. This helps make roads safer and traffic more efficient. 4. Scanning fingerprints for banking. Banks use biometric recognition, scanning fingerprints, faces, iris patterns. AI compares these to stored templates. So, if you try to open a bank account with a fake fingerprint, the AI says, "Sorry, not a match." That's security through object recognition AI. Now let's say you want to teach your own AI to recognize something new, like traditional African clothing, Ankara, Kente, Aso-Oke. You collect 100 photos of each type, label them clearly. Use a free tool like Teachable Machine by Google. You upload the photos, train the model, and then test it. When you show a new outfit, the AI says, "That's Ankara, that's Kente, that's Aso-Oke." You just built your own object recognition AI, and no coding was required. Now you might ask, why should I care if AI can recognize objects? Here's why it matters. 1. It helps solve real problems. AI can find diseases early, improve food security, prevent fraud. 2. It creates new jobs. People who train AI, collect data, and label images are part of the future workforce. 3. It needs African data. Most AI is trained with data from the US, Europe, or Asia. African people, culture, food, languages, crops, and clothing are different. So we need our own examples to make AI work for our own lives. In summary, AI doesn't see like humans. It sees images as data and patterns. It learns to recognize objects using machine learning. Neural networks help it process images through multiple steps. In Africa, AI is already used in farming, phones, banking, education, health, and traffic. You can train your own object recognition AI using photos and free tools. The future of AI needs African examples, and African learners too. Please remember, AI is not magic. It's just a smart system built by people, and you can be one of those people. In our next episode, we'll learn how AI systems make decisions, what happens after they see something and need to act. Until then, please like this video, subscribe to my channel, share with everyone. Africa should not just be watching the future, we must build it. See you in the next episode. Thank you for watching.